Bismillahirrahmanirrahim. Assalamu alaikum. Hope you all are fine. Today we have our next lecture of lipids. So first of all, a few differences between fats and oils. The fats have relatively more saturated fatty acids, whereas oils have relatively more unsaturated fatty acids. Fats remain solid at room temperature, whereas oils remain liquid at room temperature. Mainly, fats are obtained from animal sources, whereas oils are mainly obtained from plant sources. Fats having higher melting point, oils are having lower melting points. Fats are relatively more stable, whereas oils are relatively less stable. Let us see how they are showing their such properties. The triglycerols in natural fats and oil are basically non-polar hydrophobic, that is, means water-bearing and having no charges. Usually, the glycerides of unsaturated fatty acids are liquid in their state, whereas the glycerides of saturated fatty acids are solid. So it depends on their proportion in the oil and fats. The unsaturated fatty acids proportion is higher in vegetable oil as compared to animal fat. That is the reason they are showing their state. The vegetable oil showing liquid state, whereas animal fat showing solid state. Fats which are mostly obtained from animal sources having single bonds between carbon atoms and thus having maximum number of hydrogen, and thus they are also called saturated fats. And these hydrocarbon chains in the fatty acid are closely packed together in the straight form, and thus they representing solid state at room temperature. However, oils are normally obtained from plant sources and having double bond in their structure between carbon and carbon, and this causing the bands in their shape, and thus they are also called unsaturated fats. Because of such bands and kinks in their hydrocarbon tails, they are not as packed as in case of fats, and thus making them liquid at room temperature. The melting points of oil and fats has relation with their size. Melting point increases with size and decreases with unsaturation. That's why the stearic acid, which is saturated fatty acid, having melting point 71 degrees centigrade, whereas oleic acid, the cis bond, having melting point 13 degrees centigrade. And in case of linoleic acid, two cis bonds are present and the melting point is 5 degrees centigrade, and the structure is gradually reducing from stearic acid to linoleic acid. It should also be important to understand the cis and trans bonding. The hydrocarbon chains in saturated fatty acid are flexible, thus forming uniform shape, and that's why they are then easily nested together. Stearic acid structure, which is straight chain. In unsaturated fatty acid, there can be two ways the pieces of hydrocarbon tail can be arranged, that is cis and trans bonding. So what are the difference between this cis and trans bonding? In cis bonding, the two pieces of carbon chain on either side of the double bond can be upside or both sides. So both the chain can be on either side, upside or downside. Whereas in case of trans bonding, the two pieces of molecule are on opposite side of this double bond. The cis bonding are occur in naturally occurring stable oil, whereas trans fatty acids are present or occur during the hydrogenation reaction. That's why the naturally occurring unsaturated vegetable oils are having all cis bonds. But when we use the oils for frying, the cis bonds are converted to trans bonds. So what happened basically? If we use the oil first time, a little or no effect or a lesser effect will occur on conversion of from cis to trans bonding, but when we use it constantly or with multiple times, so most of the cis bond are changed to trans bond until significant number of fatty acids with trans bonds are formed, and that is the reason that such oil can show their carcinogenic action. Cocoa butter and cod liver oils are the two exceptions regarding their source and state. Although most of the vegetable oil are liquid at ordinary temperature and most of the animal fats are solid. But such examples are controversial as cocoa butter is solid and obtained from plant source and cod liver oil is liquid and obtained from animal source. Now the production of fixed oil and fats. Fixed oil and fats are obtained from different processing. They can be extracted by pressing in hydraulic presses. When the oil is obtained by pressing in cold, so the obtained oil is called virgin oil or cold pressed oil. Whereas if the pressing is carried out in heat, so the obtained oil is called hot pressed oil. They can also be obtained by using some organic solvents such as ether or other organic solvents. Animal fats are separating from their tissues by steam with or without pressure. What happened? The heat melts the fat which comes to the top and may be separated by decantation. Biosynthesis of lipids. How the lipids are biosynthesized. The biosynthesis of saturated and unsaturated fatty acid is the combination of acetate. The acetate pathway operates with acyl carrier protein. Thus, it forms fatty acyl thioesters of this acyl carrier protein, and these acyl thioesters form important intermediates in fatty acid formation. So let us see a few little detail of this fatty acid synthesis. The acetyl CoA and malonyl CoA first come to contact with this acyl carrier protein and thus acyl carrier protein and malonyl acyl carrier protein is formed, and this will result into even number of fatty acid formation from butyric acid to arachidonic acid. How the different reactions are occurred? See here. First activation, ACP combined with acetyl CoA and malonyl CoA and resulting acetyl ACP and malonyl ACP. Now, this both acetyl ACP and malonyl ACP are combined together, and by the condensation, acetoacetyl ACP is formed by the action of acyl malonyl ACP condensing enzyme. Now, this acetoacetyl ACP is reduced by the action of enzyme beta ketoacyl ACP reductase and hydroxybutyryl ACP is formed. Now, this hydroxybutyryl ACP under the process of dehydration resulting keratonyl ACP by the action of enzyme hydroxyacyl ACP dehydratase. Now, this keratonyl ACP further reduced by the action of enzyme keratonyl ACP reductase and resulting the end product of first elongation cycle, that is butyryl ACP for the formation of butyric acid. Such this butyric acid formed from butyryl ACP will resulting a number of fatty acid synthesis. How this will occur? A number of subsequent reactions occur and different type of fatty acids synthesis occur. For the saturated fatty acids, palmitoyl ACP resulting palmitic acid and stearoyl ACP resulting stearic acid, and further oleic acid can also be formed from oil ACP. The unsaturated fatty acids are produced by subsequent direct dehydrogenation of saturated fatty acid that we can see here: enolic acid, enolinic acid, and arachidonic acid. Now, the second phase of lipid synthesis, that is triacylglycerol synthesis. In this case, the glycerol 3-phosphate is come from glycerol by glycolysis, or it can also be obtained from free glycerol by the action of kinase, but it is to a lesser extent source. And this glycerol 3-phosphate will react with fatty acid CoA under the action of enzyme glycerol 3-phosphate acyl transferase and form lysophosphatic acid. And this lysophosphatic acid will further react with fatty acid CoA under the action of enzyme acyl glycerophosphate acyl transferase and phosphatidic acid is formed. In such a state, We can see first one fatty acid is attached, and now the two fatty acids are attached, and it will convert it to further diacylglycerol by the action of enzyme phosphatic acid phosphohydrolase. And this is the structure having two fatty acid, and the phosphate group is also removed in such state. Now another fatty acid CoA is added in the molecule by the action of same enzyme, that is glycerol 3-phosphate acyl transferase, and subsequent triacylglycerol is formed. So it was about the lipid biosynthesis. Now come to a few chemical properties of fats. Reaction with iodine. So it will form the compound which is colorless, and it is used for quantification of unsaturation in fat. And what is basically iodine number? It is the grams of iodine reacting with 100 gram of fat. Hydrolysis of ester basically occurred in acid or enzyme presence, whereas saponification reaction with alkali resulting soap formation. It was already studied. The saponification reaction, hydrophilic and hydrophobic region are involved. The hydrophobic region of fatty acid dissolved in oil, whereas hydrophilic stays on the surface and producing its emulsification action and wash out the dirty organ fats. Hydrogenation. Hydrogenation reaction occurs with alkene, and it can be partial or complete hydrogenation, and it usually occurs for the formation of margarine, and it will result more saturated fat because of conversion of double bond to single bond. Let us see a few basic applications of fixed oil and fats. A wide range of applications are there of fixed oil and fat. We have a summarized form. They are used in soap manufacturing. They are also used in suppositories and tablet coating processing. They are also used as dietary supplements for high quality, because of having high quality value. They are also used as emulsifying agent, and they are also used in manufacturing of paints, varnishes, and lubricants. Many of them have therapeutic applications, like castor oil is a laxative in their therapeutic action. So this is all about today's lecture, and we will continue it in our next lecture. Thank you so much. Allah Hafiz.